Hey everyone. So in today's lesson, we're going to talk about something a little bit different first, before we continue with the multiplication and division practice that we've been doing in the last few lessons. So we're going to start off this lesson by going over divisibility rules. Divisibility rules. So basically, these are some tips and tricks that will help you when you're trying to figure out if a number is divisible by another number. So what that means is, if you wanted to figure out if a number is divisible by, let's say, 2, then if it is divisible, that means that if you divide that number by 2, you'll get an answer that's a whole number, that's an integer, if you will. So basically, when you divide it by that number, if it's not a decimal, then it's divisible by that number. So if you had like a number that's divided, that you divide by 6, and it comes out to be a decimal number, then that means it's not divisible by 6. But if you divide it by 5 and it's a whole number, then it's divisible by 5. So we're just going to talk about some tips and tricks for a few numbers for how you can spot whether one number is divisible by another. So we're going to talk about just a few single-digit numbers, and then we'll talk about some examples as well. So for a number that's divisible by 2, basically the way it works is the number ends with a 2, a 4, a 6, an 8, or a 0. So that's a fairly simple one. So basically a number is divisible by 2 if it's an even number, and it's an even number if it ends with a 2, 4, 6, 8, or 0. So if you've got a whole number like 480, that ends with a 0, so it's going to be divisible by 2. But if you had like 357, because it ends with a 7, it's not going to be divisible by 2. So that's a fairly straightforward one. So we're just going to run through a few of these really quickly. It's not something that you'll be tested on, it's just something that you might find useful in the future. This is something that can be handy to know. Now the next one is, we're going to talk about divisibility by 3. And so with 3, it's neat. So a number is divisible by 3 if the sum of its digits, so bear with me while I write this and then I'll explain what it means. So if the sum of its digits are also divisible by 3. Now, I don't like this definition in words, so you can write this down because it's good for you to know, but it's not something you'll be tested on. But it's good for you to know it, but in words it doesn't really mean anything, because what I've said is a number is divisible by 3 if the sum of its digits is also divisible by 3. That should say is. The sum is also divisible by 3. But yeah, so that doesn't make much sense in words, because I've said it's divisible by 3 if something else is divisible by 3. I haven't actually explained what it means for something to be divisible by 3. So let me give you an example. So let's say a number like 912. So basically what you do is, to figure out if this is divisible by 3, you're going to add all of these digits. So in other words, you're going to go 9 plus 1 plus 2. You're just going to sum up these digits. You're going to add up all these digits. And it doesn't matter how many digits there are. There could be 3, there could be 5, there could be 50. If you sum these up, in this case we'll get 9 plus 1 is 10, 10 plus 2 is 12, so we'll get 12. And we know that 12 can be divided by 3 and give us a whole number as an answer. And if we don't know that, then we could always check it with 12 by doing 1 plus 2. But anyway, we know for a number like 12 that that it's divisible by 3. which means that since 12 is divisible by 3, this over here, this 912, is actually also divisible by 3. So I'll give you a slightly more complicated example. So let's say we got 6, 2, 0, 1, 9, 3, 4, 2. Some really long number like this. So we've got, what do we have here? We've got 62,019,342. And we want to know if this is divisible by 3, the same way 912 was. So what do? I'm going to get rid of that 912. So basically all we do is we're going to sum up all of these digits right here. So we start with 6 plus 2. So 6 plus 2 is 8. Right? So that's taking care of the 6 and the 2. Then we add on a 0, so that's still 8. So now we've taken care of those first 3. Then we add on a 1, which is going to equal 9. And we add on a 9. 9 plus 9 is 18. That's taking care of that. We've got 3 more numbers to add, so we've got that 18 from before. 18 plus 3 is 21. You don't have to write all of this down, this is just so that you can see it. And then we add on this 4. 21 plus 4 is 25. And then lastly, we've got that 25 plus 2 is 27. So I know this is all slanted and it's going down there, but basically, so all I've done is I've summed up all of these digits. 6 plus 2 is 8, plus 0 is still 8, 9 plus 1 is 10, so 10 onto that 8 is going to be 18, and then that over there is 9, 18 plus 9 is 27. So we've got that the sum of the digits is 27. And let's say that we don't know if 27 is divisible by 3. So what do? We take that 27 and we test it. We've got the number 27, we want to know if this is divisible by 3, so we just sum the digits. 2 plus 7 equals 9, and we know 9 is divisible by 3, so if 9 is divisible by 3, that is, when you divide 9 by 3 you get a whole number, which you do, it's 3. So if 9 is divisible by 3, that means 27 is divisible by 3. But if 27 is divisible by 3, that means this whole thing here is also divisible by 3. And you can check that. If you put this into a calculator, it'll give you a whole number. I haven't bothered to go through and actually figure out what the answer would be, but you will get the whole number if you divide this by 3, because it's divisible by 3. So that's what it means for a number to be divisible by 3. Hopefully that makes sense. It's a little bit weird when you write it out in words, but I think it becomes clearer when you see it in an example. So now let's do by 4, 5, and 6, and then we'll probably stop there for now, so that we can move on to something else. So divisibility by 4. So basically, so I'll say it the way I learned it at first. It's again like the thing with the 3. I don't really like it best in this way because it doesn't make complete sense in words. But if the last 2 digits of the number are divisible by 4, then the whole number is divisible by 4. So again, it's one of those examples that I don't like. It's one of those sort of statements that I don't like because it uses the thing you're trying to define in the definition. So it says if the last 2 digits are divisible by 4, then the whole thing is divisible by 4. But again, I haven't actually explained what it means for something to be divisible by 4. And so for that, it's something that you end up getting more comfortable with the more math that you do. But basically, the way it works is, if you're counting by 4s, that means 4, 8, 12, 16, 20, and you keep going. Those are all going to be divisible by 4, right? 20 is divisible by 4. If you divide it by 4, you get 5. 36 is divisible by 4. If you divide it by 4, you get 9. And so on. You go all the way up, you get to 40, you keep going. 44, 48, 52, 56, 60, you keep going. 60 is divisible by 4, you'll get 15. 80 is divisible by 4, you'll get 20, and you keep going, and then you get 92, 96, 100. That's if you keep going in the sequence of counting by 4s, you'll eventually hit 92, 96, 100. And 100 is divisible by 4, right? You'll get 25. But if you notice, the first few, when you're counting by 4s, you get 4, then you get 8, then you get 12, then you get 16, and so on, right? 20, 24, and so on. But after you get to 100, I'm going to have to write this down here. After you get to 100, the last two digits just repeat what you got at the beginning. After 100, you get 104. Then you get 108. Then you get 112, 116, 120, and so on. And you can see that these last two digits, this 04, well, that's the same as just having a 4, and we know 4 is divisible by 4. 108, same thing, 08, that's just 8. 8's divisible by 4. Over here, 116, let's say, 16 is divisible by 4. So it doesn't matter what else is there in front of this number, because every 100, it repeats, this pattern repeats. So 4, any number that ends in 04 is going to be divisible by 4. Any number that ends in 44 or I don't know, 6-4 or 8-8, all of that stuff is going to be divisible by 4 because the two-digit number without anything else in front of it is divisible by 4. So for example, 92, like I was saying earlier, 92 is divisible by 4. So any other number that ends with a 92 is also going to be divisible by 4. So 92 divided by 4 will give you, what, 23? So 392 will also be divisible by 4, and 10,292 will also be divisible by 4 because these last two digits just repeat. You get to 100 and then you go again, 4, 8, 12, 16, 20, and it just keeps going. You'll get to 200, then you'll have 204, 208, 212, 216, 220. So these last two digits are always the same for divisibility by 4. So the next one we're going to do, the last two are quite short and sweet, just like divisibility by 2. So I'm just going to write them up here. So divisibility by 5, basically the number ends with a 5 or a 0. So if the number ends with a 5 or a 0, it's divisible by 5. If it ends with anything else, it's not divisible by 5. So 56 is not divisible by 5, but 55 is divisible by 5, for example. Alright, so divisibility by 5 usually doesn't cause people many problems. Now I've got to do by 6. So divisibility by 6. So divisibility by 6. So that, because 6 is a product of 2 and 3, that is, so 6 is equal to 2 times 3. If your number is divisible by 2, that is, if it's an even number, that's also divisible by 3. So if it's an even number where the sum of its digits is divisible by 3, then the number is also divisible by 6. So a number is divisible by 6 if it's divisible by 2 and if it's divisible by 3. Alright, so those are the divisibility rules for 2, 3, 4, 5, and 6. And we'll stop there just because I want to do at least one example of multiplication and one of division in this video, since that was what I was planning to do here. And then if we run out of time there, then we'll do more practice with multiplication and division in the next video, which will hopefully be ready soon. But yeah, so these are the divisibility rules for 2, 3, 4, 5, and 6. One that I haven't put up here, but is also one you should know, is divisibility by 10, is basically if the number ends with a 0. So that's not overly complicated. But But yeah, so that's the thing I've been meaning to touch on for the last couple of videos, and it's already taken 15 minutes to get through that. So let's just do one example of multiplication and division, and then we'll see how we're doing for time. So I'm going to get rid of these. And I'm going to flip to some of the more complicated examples for multiplication and division that I did. If we have time, we'll do two for multiplication, one with long multiplication and one with lattice multiplication. But let's go through a couple of multiplication problems right here. Worst case, we'll just do two, and then I can always put out an extra sort of supplementary just practice video that's not like an actual lesson for you guys to have a look at, and that'll just be more practice problems. Worst case though, we'll do it before our test. We'll have a day where we're just doing practice problems anyway. So let's move on. We'll do a multiplication problem here. So let's start with, what do I have? I have 740,286 times 234. Alright, so this is the problem. Now to save myself a little bit of a headache with space later, I'm going to actually move this. So if you can't jot these numbers just yet, don't worry about it. I'm going to rewrite them in 1 sec. So we're going to do 740,286 times 234. So I'm just setting it up there so that I've got enough room to like carry numbers and bring things over further left as I get bigger and bigger numbers. So let's begin. We always start with the digit in the units place, in the ones place here, and we're just going to multiply it by everything in the top row, one at a time, right to left. So we start with 4 times 6 is going to give us 24. 4 goes down there, we carry the 2. 4 times 8 is 32, plus 2 is 34. 4 times 2 is 8, plus 3 is 11. 1 goes there, carry the 1. 4 times 0 is 0, plus 1 is 1. 4 times 4 is 16, carry the 1. 4 times 7 is 28, plus 1 is 29. Alright, so that's the first line, that's for the 4. Now we put our placeholder. You can put an X, you can put a 0, you can put an X inside of a 0, whatever you want. I tend to just put an X, so I'm going to leave it at that. And now we do the same thing with the 3. So we can cross out all these numbers that we carried so that we can carry more numbers for the 3 when necessary. And let's start. So we got 3 times 6 is 18. Carry the 1. 3 times 8 is 24. Plus 1 is 25. 5 goes here, carry the 2. 3 times 2 is 6, plus 2 is 8. 3 times 0 is 0, no problems there. 3 times 4 is 12, carry the 1. 3 times 7 is 21, plus 1 is 22. So we've got lots of 2's going on here. And then we're done. So there's nothing left after that 7. So we move on to the next row, and we put 2 placeholders there for this number 2, and we can cross out all those things that we carried from before. So we do it one last time. 2 times 6 is going to give us 12. Carry the 1. 2 times 8 is 16. 16 plus 1 is 17. Carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 0 is 0. 2 times 4 is 8, and 2 times 7 is 14. And we're going to add those, and we'll be done. So let's do that. We get 4 plus 0 plus 0. That's going to give us a 0. Sorry, not a 0. What am I saying? 4 plus 0 plus 0 is going to give us a 4 down there. 8 plus 4 is 12. 5 plus 2 is 7, plus 1 is 8, plus the one that we carried, that's 9. 8 plus 7 is 15, plus 1 is 16, carry the 1. 6 plus 1 is 7, 7 plus 5 is 12, carry the 1. 9 plus 1 is 10, plus 2 is 12, carry the 1. 8 plus 2 is 10, plus 2 is 12, plus 1 is 13, carry the 1. 4 plus 2 is 6, plus 1 is 7, and we get a 1. And so then you can just separate this with commas or something, because it's hard to separate it with spaces when you're actually doing the long multiplication. And then you can read off your answer, which is 173,226,924. And I believe that agrees with what I had in my notes. Yes. So that's another example of long multiplication with some slightly larger numbers. Not, of course, as large as some of the examples that you've seen before this, but it's just good to work with some slightly bigger numbers instead of just doing like 3 digits times 1 digit or 3 digits times 2 digits. This is just a little bit bigger, a little bit more involved, and gets your brain working a little bit harder. So we'll wrap up with one example of long division, and then that should hopefully be enough practice for you guys to start your assignment and hopefully not run into any problems. If you prefer lattice multiplication, then you can do that as well, but I don't think we're going to get a chance to do an example of lattice multiplication in this particular video. So let's do our long division example, and then we'll call it a day. So we're going to do 663,671 divided by 42. Alright, so I'm going to rewrite this again in just a sec. I'm just going to move the numbers around a little bit. But that's what we're working with. It's 663,671 divided by 42. So I'm just going to move those a little bit. So we're going to have 663,671, that's what I said, right? Divided by 42 over here. Alright, cool. So the first question we ask ourselves, it's a little bit redundant when you've got a 2-digit divisor, but it's always good to just be in the habit of asking yourself the same question to start the problem. So we ask ourselves, how many times does 42 go into 6? Now obviously when your divisor is 2 digits, it's never going to fit inside a single digit number, so we can just move on and consider the first 2 digits instead. So we ask ourselves, how many times does 42 go into 66? And we get that 42 is only going to go into 66 once. So we're going to do 42 times 1 is equal to 42. So that's going to go down here, and we're going to subtract. Now I'm actually going to move this over, and we're going to build a little multiplication table for 42. Not a crazy long one, but it'll prove to be useful. So 42 times 1 is 42. And then we're going to build on this a little bit later with some bigger and bigger numbers. Alright, so just leave that off to the side for now. So 66 minus 42, 6 minus 2 is 4, and 6 minus 4 is 2, so we're left with a 24, and then we pull down the next digit, which is a 3. So now we need to ask ourselves, how many times does 42 go into 243? And so this is where multiplying 42 by 1, 2, 3, 4, 5, 6, 7 is going to come in handy, because it'll show us the answer to this. So let's go and do that. So basically 42 times 2 we get 84, and the pattern that you can use to build the rest of these is, since we're going up by 2's in the 1's place every time, you can just put 2, 4, 6, 8. Easy as that for the 1's place. And then we're going up by 4's in the 10's place. So we get 4, 8, and then we end up getting a 12 here. So 2 in the 10's place, and then 1 carries over to the hundreds, and then a 6 there. So basically I've independently done the 2's in the 1's place here become 2, 4, 6, 8. And then the 4's in the 10's place go up 4, 8, 12, 16. Then we have to be careful with 42 times 5, because we get a 0 here, but that would actually be a 10, so it would carry, and if you do the multiplication, you get 42 times 5 is 210. But this is where the pattern breaks just a little bit, so you have to be careful that you remember to carry that 1. If you're doing it just by counting and not by actually multiplying it, you can then go 2, 4, 6, 8, 0, and that'll continue, 2, 4, 6, 8, 0 again. But then this will go 4, 8, 12, 16, 21 because because that was actually a 10. So we bring an extra plus 1 into the tens place. But basically what we get is that 42 times 5 is 210, which is close, but maybe not close enough, so we can always test by doing one more, 42 times 6, and we can do the same process, or we can just multiply it out, and we'll get that 42 times 6 is 252, which is too big for this number, right? So that means that 42 times 5 is our magic number, which is going to be 210. So because it's 42 times 5, that 5 right there, we're going to put that 5 up top. 42 times 5 is 210, so that's going to go down here, and we're going to subtract. 3 minus 0 is 3, 4 minus 1 is 3, 2 minus 2 is 0, and I'm going to pull down the next digit, which is a 6. Now we ask ourselves, how many times does 42 go into 336? And this is where this table will come in handy, because we can just keep building on this. We don't have to start from 42 times 1 again. We can just keep building on this one. So let's do 7, 8, and 9. 42 times 7, 42 times 8, 42 times 9. So 42 times 7, if we just keep going with this pattern, we'll get 294. And then 42 times 8, so we'll get 336. Right, we were just going 2, 4, 6, and then we're going up by 4s, 25, 29, 33. And if you look at that, it matches this one exactly. That was actually unintentional. I just picked two numbers out of thin air, and I wasn't thinking that anything like this would work out so perfectly in the middle. But it is what it is. So 42 times 8 is going to give us 336 exactly. So we put that 8 up there. 42 times 8 is 336, so that goes down here. We subtract, and we get 0. Right? 336 minus 336 will leave us with 0. So we bring down the next number, that's going to be a 7. We bring that over here. 42 clearly does not go into just 7, so we're going to put a 0 up there. So remember, you want to answer that question with a number. How many times does 42 go into 7? 0 times, so you put a 0 up top. 42 times 0 is 0. If you want to go through the subtraction, you can. 7 minus 0 leaves you with 7. And then you pull down the last digit, which is a 1. So we've got a 71 down here now. So we ask ourselves one last time, how many times does 42 go into 71? Now we can use this table, and we'll see that 42 times 2 gives us 84, which is too big. So it has to be just 42 times 1, which is 42. So we put the 1 up there. 42 times 1 is 42, so we squeeze that in here. And if you do that subtraction, I've run out of space on the board, so I'll just slot it in over on the side, but this should ideally go underneath there. So if you do this subtraction, you do 71 minus 42. If you want to do it the long way, you can borrow, so you turn the 7 into a 6, and you get 11 minus 2 is 9, 6 minus 4 is 2, so we get a 29 that should be sitting down here under the 42. Maybe I can squeeze it in, even though you might not be able to read it. So there's a 29 down there now. Now, because we've run out of digits to pull down, that's all we can do for this problem. So this 29 becomes our remainder. So we're left with R29. I've just put a capital R there for our remainder. And so basically we're done the problem. Our quotient, our answer, is this thing up here. So we get that our final answer to this problem is 15801. So 15,801 with a remainder of 29. Alright, so hopefully that makes sense. So we've gone through divisibility rules in this video, as well as one example of long multiplication, and now one of long division. Hopefully that's refreshed your memory on both of those things in case you needed it. Unfortunately, we didn't get time for lattice multiplication in this video, but hopefully we can get around to that in the near future. Also in the near future, we'll start doing long multiplication and division and lattice multiplication involving decimals. The process is almost exactly the same, but I just want you guys to see a couple of examples using decimals so that it doesn't scare you in the future when you have to multiply or divide with decimals. So this process is basically the same. We're just going to have to pay a little bit more attention to, you know, decimal points and where we put them and stuff. But in general, the idea is the same for division as well as for multiplication, so we'll see that in the near future. But I believe after you get to this video, there will be an assignment which will focus more on division, but there will also be a little bit on multiplication in there, most likely. I still have to make that at the time of recording, so that will be out for you guys soon. And you guys can get in touch with me if you have any questions. But if not, I will see you in the next video. Have a good one.